Hi guys, and welcome to this Houdini video tutorial. Today we're going to take a look at using attribute transfer to take attributes from two separate pieces of geometry and have them transfer over and be able to affect one piece of a geometry based on the distance from another piece of geometry. So it's a really nice effect and let's kind of get started. So first of all, I've got a fresh Houdini scene. I'm going to go down to my network view, hit tab and type in geo or geometry. Select the node and drop it in. We can press I to go inside and then hit delete on the file node itself because we don't need it. Then I'm going to drop in a grid and a sphere object. Remember, just hit tab and start to type the particular object themselves and you'll be able to drop the nodes in. Let's first work on our grid and then we'll get our sphere set up as well. So first of all, I'm actually going to increase the overall size of my grid. So I'm just going to hold down the middle mouse button over the parameter itself, which will give us our interactive numeric ladder, and I'm going to increase this to maybe something like 20. I'm then going to copy the parameter of rows by right mouse button clicking on the parameter, and then I'm going to paste that channel reference into the columns. So that kind of sets up a relationship between our rows and columns straight off the bat. You can just type this expression, which is nice. Which is CH, open brackets, and then the particular parameter that you want to associate with. And if you want to find that out, if you hover over any particular label, you will actually get the parameters here. So for size, it's size X and size Y for these two specific channels. So now that once that relationship is set up on rows, I'm going to increase this to about 100. And next we're actually going to assign an attribute that we want to transfer from one object to another. Now both of these attributes have to be exactly the same, and we're just going to use color for demonstration purposes. So I'm going to drop in a point node by hitting tab in our network view and typing in point, connect it up to our grid and visualize the node. Now at the minute it's affecting the point position by default, and it's just saying return itself, so do absolutely no change to the incoming geometry. We're going to change this attribute to color, and instead of being itself, we're actually going to say set it to a constant value so that we can have control over what this value is. And we're going to type in 000, which will turn our object black. Now that that has been set up, we can actually focus on our sphere. So let's visualize our sphere node. And we want to change it from primitive to a polygon object, and maybe increase our frequency just a little bit, maybe up to about 5. And similarly, we're going to assign a point node to it to create some color on our object. But to kind of save a bit of time, you can copy and paste this node, or if you want to copy something, you can just hold down the Alt button and left mouse button click and drag, and it will copy out it will produce a copy of that particular node and its node string. So let's connect up our sphere instead of the grid and visualize this point node too, and we're going to change the color from black to a positive of the red. So value of 1 will change it to pure red. Next, what we want to drop down is the ability to transfer this color to our grid based on where this sphere actually is. So we're going to do that by dropping in an attributes transfer. And once we kind of drop that in, we just need to connect up both of our point nodes. So Once that is connected up, we have our grid to the first input and then our sphere to the second, and when we visualize that particular node, you'll see that it's already started to work, but perhaps a little bit too well. And what we actually need to go into is our conditions on the attribute transfer node. You can actually say here that we have a kernel radius, a sample count, a blend width, and also a distance threshold, which is kind of analyzing how far away from each point should it actually transfer those attributes for. If we start to dial that down, you can actually see we get a tighter circle around where our sphere was. And it's quite useful to actually just template the previous object. So if we go up to our sphere node and template it, either by clicking on this flag here or on the template icon in the radial ring, you can actually see the position of our sphere, and based on where that is, it will actually transfer that color attribute across for us. And if we were to drop in a transform node, so hit tab and drop in a transform, and put it between point node 2 and the attribute transfer, this will allow us to move that particular sphere. And if we hit enter, we can activate the tool, T for translate, and you'll see that as soon as we start to move that sphere around, that color data is actually moving with us. So again, it allows us to have this entirely set up, and we can kind of come back and do some animation on this later. Now, we're only using color so that it's easy to visualize, but you don't need to be transferring color data. It could be any particular attribute that you set up, but it does need to exist on both streams to work. Now, you might wonder why you might want to actually go about doing this, but we can actually access this particular data group based on its value. So we can actually drop in a group by expression node, so group expression, and we'll put that after attribute transfer, and we need to set this to points, and we need to name our group, so it's going to be called group 1, that's fine, and the vex expression that we're going to type in is at CD. And if you had a different type of attribute set up, it would be something else, or whatever the name of the attribute is. But we have color data, so that's attribute CD. And we're going to say, is that greater than 0.2? And because it's an if statement, it returns either 1 or 0. And if it's true, it's going to add that point to group 1. If it's false, then it doesn't get added to group 1. And you can see that we now have all of those points actually grouped for us. And what's really nice is that any surface level operator usually has a group kind of selector up at the very top. So if we drop in a transform node after this and hook it up and visualize it, you'll see that at the very top it says we can isolate a transform, but only on a specific group. So if I say only work with group 1, now if I do like a negative translate in the y down by 0.8 or something even more, so -1, you can see that we're actually affecting only those points. And again, that is only based on where the sphere actually exists in 3D space. So if we were to kind of move that sphere, you can see that we're actually getting indentations based on where that sphere is. Now at a later date, we can actually show how this works in animation, because it's only working where the sphere currently is. Houdini can actually use some simulation data to remember that previous data and keep the indentations over time. But we'll kind of have a look at that at a later date, because that kind of a setup would be used to do perhaps footprints in snow or indentations in mud or sand, and you can also do wet maps. So for instance, if water was flowing down a street, you would need to affect a shader based on where that water has been, and you can use that by doing attribute transfers. So this was just a super short kind of video showing you how to get attribute transfer to set up. But the main thing to kind of note is that both streams, the object that you're transferring from and the object that you're transferring to, need to have the exact same attribute set up, even if it's completely 0 on one stream and then completely 1 on the other. Okay guys, stay tuned for more video content. Okay, thanks.